This is exponential and logarithm functions for the exam review. We're going to identify the domain and the range of our function. So we see that this is exponential. It's half, so we know that it's falling. We know it's been translated downwards, so it's going to come down with an asymptote down here at y equals -5. And the 3 just means that all the points are stretched up 3 times as far, but it's still approaching the -5. So the range is greater than -5 and all real numbers. Okay, story problem. Identify the equation that would be used to solve a given problem. Suppose you deposit $2,000 in a bank account. Find the balance after 5 years if the bank account pays 2.5% annual interest rate compounded monthly. Well, what we think about is the account. Take your initial amount that you deposit, 1 plus R over N NT. That's our formula we'd use. So we know we're going to have $2,000, 1 plus 0.025 over 12, and 12 times 5. So that would be 60. 12 times 5. Alright, so it's not that, it's not that, so it's one of these. It's not that, so we need to be sure you write your annual interest rate as a decimal of a percent. Identify the domain and the range. This is a logarithm. So we know that the logarithm x minus 3 means it's going to be translated to the right 3. And it's going to come down and approach the x equals 3. So your domain is greater than 3, so it's one of these two. And it's all real numbers. It goes up and down. So it's C. Evaluate the expression. So, a couple different ways we can think about this. If this equals x, then it would be 2 to the x power. The base to what power equals 1/4? Well, this is 2 to the x power equals 4 to the -1 power. And this is 2 to the x power equals 2 squared, because that's what 4 is 2 squared. Now you've got the bases the same, so x has to be -2. -2 for an exponent. Negative would mean put it in the denominator, and the 2 would square it, so that makes sense that the 2 becomes a 4 in the denominator. Identify the transformation that took place to make this parent function and translate it into here. Well, we know that there is a vertical stretch by a factor of 2. And translated 3 units, it's always the opposite, 3 units left, and for the k value it's exactly that. So, and 4 units down. We're going to find the inverse. Well, first we think about this as y equals log, this is base 10 because there's no base that's written, 3x minus 1. We're going to do the inverse. We're going to switch our x and the y. Now we're going to rewrite this because we don't need a logarithm. Where it would be remember, a logarithm always equals the exponent. So the base is 10. X is your exponent because that's what a logarithm always equals, the exponent. So this is going to be 10x minus 1 divided by or plus 1 divided by 3 equals y. Let's see what they have here. There it is. Okay, graphing this. Well, the way we start to graph this is we're first going to focus on y equals log base 3 of x, and then we'll translate it. So we're going to do 3 to the y power equals x, and we're going to make a table out of that. So we pick values for y. So when y is negative 1, we get an x that equals 1/3. When y is 0, we get 1. When y is 1, we get 3. It looks like we might even be able to go to 9. So at negative 1, well, when y is negative 1, we're at 1/3. When y is 0, x is 1. So there's our logarithm. If you type this into a calculator, you won't see it going down so much. It will seem like it stops, but it does not. And then we're going to translate this. 2 units left and 3 units up. And that's y equals log base 3 of x plus 2 plus 3. Translated 2 to the left and 3 up. Where this graph was y equals log base 3 of x. The domain, the x values, our x's are greater than negative 2. You could write this in interval notation, saying 2, it does not include negative 2, so it'll be a rounded bracket, and then it goes to infinity to the right, and of course it never touches infinity because it's not a location, and then it's all real numbers. And for interval notation, we call that negative infinity to positive infinity. We have an asymptote right here at x equals negative 2. We made our table. Excellent. we're going to condense this. So that means if it's minus, we're going to make a fraction, which is log of x over y, then plus z means that the z is going to go on top. So xz over y, there we go. We can bring our a value up as an exponent. And then we can write this as log, it's a common log, base is 10, of 3x cubed. Here we could separate this by saying 3 times 16. 3 times 16 is 48, so that looks okay. That would be bringing your exponent up to make it 4 squared, which is 16. The plus of a logarithm means you're going to multiply it to the 3, so 16 times 3 is 48. That's okay. This would be 8 times 6 is 48, so that looks alright. And this would be 9 times 8, which is 72. This one's not okay. So which of the following are not correct? And that guy's not correct. Because when you bring the x up there, or the leading number up there, you're going to get log base 3 of 3 squared. That's not 6. That's not 6 times 8. That's 9 times 8, which is 72. Okay, first we'd bring our 3 up, which is going to make this 2 cubed minus log base 3. So that's going to be 8 times 9, which is 72, divided by 3. And 3 goes into 7 2 times, so it would be log of 24. I'm going to try to solve this. So what we need to have, this would be 5 to the second power. If these two bases are the same, then the exponents have to equal each other. So negative 3x minus 1 has to equal 2. So we're going to add the 1 across and divide by the negative 3. So x has to equal negative 1. There it is. We'll solve the given exponential equation. We have 3 to the x minus 1 equals 9. Well, we can write 9 as 3 squared, and that 9 is raised to the power of 2x plus 7. So that means we're going to have x minus 1 that has to equal 4x plus 14. If the bases are the same, then the exponents have to equal each other. That's 3x, going to minus the 14 across. That gives us negative 15. And x is going to be negative 5. Alright, we would solve the logarithmic. Log base 4 of 2x minus 1 is going to equal 2. And it'll be 2 to the second power, or 4 to the second power. equals 2x minus 1. At 16 equals 2x minus 1. Add that across and divide by 2. It's going to be 8.5. Solve the given exponential equation. So we're going to subtract the 7. That gives us 4 to the 2x minus 5. We subtract 7 from this, and we're going to be at 64. Now we need the bases to be the same. 4 cubed. Now the 4's are the same, so the exponents have to be equal to each other. So x has to be 5.5. And that doesn't look like it's an option. Okay, where did I mess up? Subtract this across. Should be 64. 4 cubed. Oh, I'm adding 5, my bad. Adding 5, not 8. 8 is what it becomes. So this becomes 8. And when I divide by 8, I get 4. There it is. That's the good part about multiple choice. If you know what you're doing, you can go back and find your correct answer. Solve the given exponential. Well, to solve for an exponent, we have to use a logarithm. But first we got to move this 3. So we're going to have 5x to the negative 6 equals 8/3. Now we're going to say log base 5 of 8/3 equals x minus 6. And then we'd add the 6 across. So we can take our graphing calculator, and if we hit, let's see how this works, alpha y equals, move over to, there's our log base. So we have a 5 and then 8 divided by 3. It gives us that value plus 6. So 6.61. There it is. So here we have 2x plus 1 equals 9. We'll divide by the 2. That gives us 4.5 or 9 halves. Now, we can't get into this x, so we have to write this exponential form. So 3 to the 9 halves is going to equal 2x plus 1. So 3 to the 9 halves minus 1, all divided by 2. So 3 to the 9 divided by 2 minus 1 divided by 2. 69/65. So the logarithm, if it's plus, that means we're going to be multiplying. So then we're going to write this as 3 to the third power equals x squared minus 6x. So this is x squared minus 6x minus 3 times 3 times 3 should be 27. So we'd factor this apart. What is that? 9 times 3 is 27. It'd be a negative 9, and a positive 3 would add to be negative 6. So x is going to be 9, or x is going to be negative 3. Those are both possible answers. We're going to solve the logarithmic equation. So we're going to minus 5 to get us 12 divided by 3, which is 4. And this is e to the fourth power equals x minus 7. So we add the 7 across. So e to the fourth power plus 7. 61/60. Solve the equation. Right, that's interesting. Alright, no parentheses here, so the 3 is separate from the x. So when I see, this is say log base 2 of x minus 3 minus log base 2 of x is going to equal 3. So we can write this as log base 2 of x minus 3 divided by x. So this is going to be 2 to the third power equals x minus 3 over x. So 2 times 2 times 2 is 8. And then we can solve the 8x equals x minus 3, 7x equals negative 3, x equals negative 3/7. There we go. We can always check our answer. So if we take negative 3 divided by 7, and then we say second, or the alpha, second over to window, down to the log base. The base is 2. We have our answer minus 3. Alright, that's because we can't be negative there. Which means when we checked our answer, we always got to take our answer and plug it back into the problem. And when we plug it back into the problem, we see that a negative and your negative, this is 2 to what power equals this negative number, and there's no solution for that. That was a good one for us to check. So no, it's not going to be negative That's what we get mathematically, but that gives us kind of like an extraneous solution. It gives us an answer that's not true. It doesn't work back in the original problem. No real solution. And that's everything for logarithms.